Okay, so what I want to talk to you about first is just get some definitions down so we're all in the same place. So we're going to do operations. That's add, subtract, multiply, and divide with positive and negative numbers. So a couple things that I'm going to be referred to is I'm going to be using some words like opposite and absolute value, and I want you to know what those mean. So let's opposites. So if we think about opposites in the real world, we might talk about high and low. We might talk about wide and narrow. Okay, those are opposites. But when you talk about opposites in algebra, we're talking about opposite numbers. Okay, now what does it mean to be an opposite? Let me show you an example, and I think you'll remember it. If I have 3, its opposite would be, right, negative 3. If I have negative 7, its opposite would be 7. Exactly. So look at what that's talking about. Okay, that's opposite numbers. One way to think of it is if we look at our number line. A number that's on the opposite side of 0. Okay, so 2 and negative 2 are opposites. So they have the same number, same digits or number, but the opposite sign, meaning one is positive and one is negative. So those are opposites. Okay? Now, when we talk about absolute value, if we were in the classroom right now, I might say, okay, how far away am I from you? And we could step off how many things we are. Now, when we talk about positive steps and negative steps, no, we just talk about steps. What is the distance? And that's what absolute value is all about. It is the distance from 0. Okay, and a distance is not positive or negative. It's just a distance. So if I talk about the absolute value of negative 4, so the absolute value, this is red, absolute value, that's what those two long lines mean, of negative 4. Well, what is the distance from 0 to negative 4? Well, it's 1, 2, 3, 4. Okay? What is the absolute value then of 2? Well, what's the distance from 0 to 2? It's just 2. So that's what I mean by absolute value. We're going to use that information when we're talking about some stuff here. Okay? So if we talk about addition of positive and negative numbers, we're not going to use calculators. We will later, but for today, we're not going to use calculators. Okay? If it's a really big number or something, we're going to have the teacher do it. So Mr. Huntley is going to use the calculator if we need to. Or I'll use the calculator, but don't get one out for you right now. So I want you to look at these two true statements. 4 plus 5 equals 9. Negative 3 plus negative 4 equals negative 7. Okay? And then look at this statement. If the signs are blank, then blank, the absolute values, so do something with the absolute values, and then the sign stays the same. Oh, and then the sign stays the blank for the answer. Oops, I might have already given some away. So look at this. Think for just a second. If the signs are, see how both of these have the same sign? These are both positive. I get a positive. These are both negative. I get a negative. So if the signs are the same, then, well, what did I do with 4 and 5 to get to 9? What did I do with 3 and 4 to get to 7? I added, but what I actually added was the absolute value. This right here, I put this in so that mathematically I'm correct. Okay? We could just say add the numbers, but we have to realize we're actually adding the absolute values. I'm taking the 3 and the 4, and I'm getting 7. Okay? And then the sign, well, two positives, when I'm adding positives, I get a positive. When I'm adding negatives, I get a negative. So the sign stays the same. Signs are the same, the sign stays the same. Okay? Let's look at these true statements. Negative 3 plus 7 equals 4. 4 and negative 9 equals negative 5. 12 and negative 4 equals 8. Negative 13 and 7 equals negative 6. What pattern do you notice there? Another hint, too, is we talked about if the signs are the same. So notice here, my signs are different. Then, what do I do? What did I do with 3 and 7 to get to 4? Right, I subtracted. And what I actually subtracted is I subtracted the absolute values. I took the absolute value of 7, and I subtracted the absolute value of negative 3. Okay? This right here is a technicality that I feel more comfortable if I'm going to say it to be mathematically correct. Okay, if the signs are different, then subtract and take the sign of the, well, what did I take the sign of here? Here I had a negative and a positive. I came out positive because I took the sign. Here was negative. The 9 is negative, and it ended up negative. Take the sign of the larger absolute value. So if I'm looking here, that'd be the absolute value of 4 and the absolute value of negative 9. I took the sign of the larger absolute value, so it's the larger absolute value. Okay, so let's just look at some examples. If I have -2 plus -8, what does that give me? Signs are the same. Signs are the same, so I add, and the sign stays the same. Okay? -11 and 3. My signs are different, so I'm going to subtract 11 minus 3, which is 8, and I'm going to take the sign of the larger, which is bigger, 3 or 11. The 11 is, so I take the sign of the 11, I get a -8. Okay? Try this one on your own. -4 and 12. Did you subtract and get an 8? And is it positive? Yeah, because 12 is bigger. Okay, so those are just some examples, and if I were there, I'd probably do a few more with you, and just to make sure that we understand it. Okay? Good. I think you get the idea. We're going to get to practice some for part of our homework today. Now we're going to talk about subtraction. And again, we're still with no calculators. So if I have 7 minus 5, what's that equal to? 2. That is right. We know that's all 2. Here's the really cool thing with math, though. I can rewrite this. Because look at this. From what we just were going through, look at this right here. 7 plus -5. My signs are different, so I subtract. I take the sign of the larger, the 7 is positive. These mean the same thing. Now, if I look at this, what did I do? Well, I changed subtraction to addition, and whatever follows subtraction to its opposite. Okay, so change subtraction to addition, and anything that follows it to its opposite. So we talked about opposites on the page before. So the opposite of 5 is a -5, right? So I changed subtraction to addition, anything that follows to its opposite. Now, that's mathematically what I need to know. But how am I going to remember it? Well, the way I remembered it for the longest time is I always make 2 marks. Make 2 marks. I'm going to change subtraction to addition, whatever follows to its opposite. Well, when I was teaching with a student a couple years ago in community college, she taught me this. I thought that was so great. Cross a line and change a sign. So when I had 7 minus 5, I could cross a line and change the sign, which I thought was an awesome way to remember it. Okay? And then we just get to follow the rules for addition. So let's do a couple. So here we go. We're going to cross the line. Now, in 7th grade, what we were taught to do was to rewrite it to be 5 plus -12, which is great. That's awesome. But I get lazy sometimes. So I just cross the line and change the sign. Then I go to my rules for addition. My signs are different, so I subtract. I take the sign of the larger. Okay? Cross a line, change a sign. Now I use my rules for addition, -3 and -8. That's going to be a -11. Now, some people don't like this, and as math teachers, we sometimes disagree as to how this should be taught. I worked with a lady who was a really good math teacher. She did not teach her students, to cross a line and change a sign. So I'll leave that up to you. I do this because I stink at negatives. I'm not very good at drop them. I do all these things wrong. So by doing this, I make less mistakes. Not perfect, but I make less mistakes. Okay? So look at number 3. I'm going to cross a line, change the sign. My signs are different, so I subtract. Take the sign of the larger, so it's going to be a -4. Try number 4 on your own. Go. So I cross this line, change the sign. I get a -34. Okay? Good. Now, on this, just looks a little more complicated, but you guys, you can do this. So cross the line. If it's subtraction, cross the line, change the sign. Cross the line, change the sign. Cross the line, change the sign. Ah, that line's already crossed. It's an addition sign. I don't do anything. Now, I can go from left to right. We'll talk more about that when we get into order of operations here in just a bit. Or what I sometimes like to do is I like to put all my positives together, add those up, and then I put my negatives together. So 8 and 6 is 14, plus 5 is 19. -3 and -7 is a -10, so I get 9. Now I could have also gone left to right. 8 plus 6 is 14, plus a -3, that would be 11. 11 plus 5 is 16. 16 plus -7, my signs are different, so I subtract, and it would be 9, take the sign of the larger 16. My brain doesn't work that way as well. Ugh. So that's the reason to do that. Try number 6 on your own. Go. So for number 6, I can also cross the line, change the sign. Addition, can't cross any lines, it's already crossed. Cross the line, change the sign. Now, I can look at this one again. Look at this. I have a negative 12 and a positive 12 because I can add them in any order. That's the beauty. If everything's addition, you can do it in any order that you want to. Okay, subtraction, not so much so. So if it's addition, I can. And look at this, negative 12 and positive 12. See how they cancel each other out? So then I just take negative 5 and negative 4, and I get a negative 9. Bam. Okay, now look at this next thing. If you want to, you can pause and write all this down. But I just want us to look at patterns. What's going on? Because multiplication and division of positive and negatives is way easier than addition and subtraction. So just take a few minutes, look at this, pause your video, and look at what's happening with that. Just pause it and look at what's going on. What can you notice? Okay, do you see what's happening? I took a negative and a negative and a negative, and I got a negative. But when I take a negative times a negative times a negative times a negative, I got a positive. Count up all these. 1, 2, 3, 4, 5, 6, 7, 8. Positive 2. 1, 2, 3, 4, 5, 6, 7. Negative 2. What do you notice? If I have an odd number of negatives, the answer is negative. And if I have an even number of negatives, my answer is positive. Okay? So that's one way to remember it. Odd number of negatives, my answer is negative. Even number, my answer is positive. The other thing that you can do that I think is kind of fun is pretend like they knock each other out. So I have this negative and this negative, bam, knocked out. No more negatives, so I have one negative left. Okay? This negative and this negative knock each other out. This negative and this negative knock each. I'm not a violent person by nature, but I just think that's kind of a fun thing to do. Okay? So just kind of match them up. That one cancels out that one. Okay, they don't become, so they cancel each other out. Cancel out, cancel out, cancel out, cancel out. Oh! Cancel out, cancel out. I have a positive. So you can think of it either way. Just find a way to remember if it's positive or negative. Okay? So it'd be great right now if you could just practice some problems with positive and negative, and maybe use your whiteboards to do that. Just pull out the whiteboards and just practice some problems that Mr. Huntley gives you. Okay? So if you have some questions, make sure you ask Mr. Huntley. He knows what he's doing. He's awesome. That's positive operations with positive and negative numbers.